Hello, this is Dr. James Camp from Lee College in Baytown, Texas, and this is my presentation on objects and classes in C++. Now, here it's important to note that objects and classes are probably the thing in which C++ is most different from the other C family languages we've been discussing in this class. I occasionally talk about how the things I teach apply to the worlds of Java or C# programming, and Java and C# are fairly similar to each other in how they handle objects and classes, but very different from C++. And of course, standard C does not have objects or classes. That's what makes C++ a plus language. Okay, so let's continue with objects and classes in C++. So before we get into the hows of object-oriented programming, let's get into the whys. What is an object and why would you want to use it? So far, we've done our programming divided into data. For example, we might have had a struct point that contained an x, a y, and a time value. Okay. And we've had functionality separate to that. We might have had functions called launch that took information about the rocket and a starting point, and fly, which took point P and returned a point. Okay. So the idea of object-oriented programming is that you can take these two concepts and merge them together. So you could conceivably have one object of type rocket that kept track of its position as a point, as an x, y, t, for example, but would also keep track of its own weight, or mass, I guess we should say in a physics sense, its drag coefficient, and its thrust capability. And it would keep track of all those things for us so we didn't have to remember them in the program. And then it would have built-in functions called launch and fly that didn't need to be passed any data because they already have access to these pieces of data here in the rest of the rocket itself. Okay, so by taking our data and our functionality and merging them into one structure called an object, we can model real-world objects which know what they are and what they can do. Okay, now let's talk a little bit about the why of why you would want to do this. We've seen objects, we've used objects so far in C++. The string data type that we've used, the vector of, say, int that we've used, these are objects that each keep track of their data. The string keeps track of a string of letters. The vector keeps track of an array that can change its size of integer in this case. And the cin/cout streams that we've used for input and output are also objects. They keep track of the stream of input coming in from the keyboard or the string of output going to the console window, respectively. Objects also make graphical programming, graphical interface programming. I won't say possible because we did some of it before objects, but we certainly make it simpler. Okay, if you have a window and it's taking input in the form of text and it has a couple of buttons, each one of these buttons is a button object. This is a text box object. Okay, and when the user clicks one of these buttons, it takes the text from the text box and applies it to, I don't know, some data structure that we're storing that text in. But it queries the text box object to find out what text has been typed in there since the last time the user hit the button or whatever. So we can obviously do a lot of programming things using objects. But these are objects that have largely been created for us. Why would we be interested in making our own objects? Well, we just talked about the motivation for making a rocket object. Okay. But why is that any easier than doing the programming the way it is? Well, so far we've created a point. We've created a struct point in previous lectures that held x and y and t in milliseconds. Okay, and then later in our program we created point rocket location, perhaps, and we called a function fly and passed it rocket location. Okay, actually, we set the new rocket location to fly and gave it the input rocket location. Okay. So far that doesn't look too terribly difficult, but what if we don't want to simulate the same rocket every time? We've been assuming that the fly function, wherever it is up here, point fly point P, we've been assuming that it knows everything there is to know about the rocket, its mass and its thrust and its drag. Well, what if those things change from time to time when we run the program? What if we're designing a rocket and those variables change, or if perhaps we're simulating more than one rocket? In that case, we'd have to pass the fly, not just our point, but also a double for thrust, and a double for drag, and a double for mass, so that we know what the effects of gravity are on this and how much drag it's incurring and how much thrust it's producing at each moment. So now our program starts to look like this. Rocket location equals fly of current rocket location, but also we have to pass it thrust, drag, mass each time. And what would happen if we were keeping track of multiple rockets? Well, we'll get to that in the next slide. But we could do all of this with an object where we define class rocket And we had fly and launch, and then we had location and thrust and drag and mass all stored inside the class. And now our code looks later like this. Rocket R1, say. We set it up with thrust and drag and mass, and then we call r1.launch, and while it's in the air, r1.fly. So in this setup, we only have to set the rocket's thrust and drag and mass once, and then for the rest of the code, we're just letting the rocket object simulate itself. We don't have to keep track of thrust and drag and mass throughout the entire program and keep passing it to our function over and over and over again. So that brings me to the third part of our motivation, and the real reason why object-oriented programming is handy for writing our own programs. What if we had, what if we were simulating multiple rockets? Maybe we wanted to compare two different rocket designs, or we were simulating a battle scenario where different types of rockets were being launched from different places to different targets. There are all sorts of reasons why we might want to simulate multiple rockets. In this case, our old-fashioned way of doing it would be to call fly, and we have to pass location 1, thrust 1, drag 1, and mass 1, and then we have to go back to fly, location 2, thrust 2, drag 2, mass 2. Okay, so we could do it. But in our object-oriented scenario, we just set up rocket 1, and we call rocket1.fly, rocket2.fly, and this way we could theoretically even set up a whole array of rockets, a whole vector of rockets, however we wanted to do this, and each one we just call its fly operation, and it simulates itself. We don't have to keep track of all of these extra variables for each rocket throughout the entire program. So object-oriented programming has a lot of power, not just for writing cool programs, but also for writing useful programs, simulations of various real-world objects. I'm using a rocket here, but you could do a simulation of cars, trucks, and even pedestrians walking around in a downtown area to simulate traffic flow. You could do a simulation of multiple cash registers running at a retail store and how each one is accumulating transactions during the day. You can do all sorts of things. Any real-world object can be modeled as a C++ object. Okay, now in C++, you never define something called an object. You define something called a class. And a class is a type of variable, just as struct was a type of variable for a data structure. Let's say we wanted to call our class motor vehicle. Okay, And our class motor vehicle might have properties like speed, color, horsepower. There are all sorts of properties that a motor vehicle has, no matter what kind of motor vehicle it is. And then later in the program, we can define motor vehicle my car and define it with all the variables like my car is black, it has a 4-cylinder engine, has 4 doors, whatever properties this motor vehicle needs to set up. We could do then another motor vehicle my bike for my motorcycle. It's orange is its accent color. It has 2 cylinders and it has 0 doors. Okay. And then we could do motor vehicle your truck and say that your truck is white and has 6 cylinders and 2 doors. Okay, so we get the idea. All of these different objects, my car is an object, my bike is an object, your truck is an object, but they're all members of the class motor vehicle. And they'll all have similar behaviors. They'll all have methods. We call a function that's applied to a object a method. They'll have methods like drive and park and that sort of thing. Okay, so let's look at how we define a simple class in C++. We use the class keyword and then we give it a name. So we're going to simulate here a common first example in, at least I've seen it a few places in object-oriented programming. Just one of those little click counters that you might use if you were counting people coming into a performance event, or that a teacher might use to count how many correct answers there are on a multiple choice test or something like that. So just a counter, okay? Then we use the keyword public to define the parts of our class that are accessible to people outside that object. And this is where C++ has a major difference from Java and C#, is that in those two languages, each variable and function, method, whatever you want to call them, that you define for this class gets its own public or private identifier. In C++, you define a public block and then a private block. So general rule of thumb in object-oriented programming is to make your functions public, your methods public, and your data private. So we'll say void reset, because we need to be able to reset the counter back to 0. Void count and int get count. Okay, and then we'll have private down here our data, which is int count, whatever our current count is. Starting in C++ 11, we can initialize, auto-initialize count to 0, so that when we create a new counter, that count is automatically initialized at 0. But if you're using an older compiler, that won't work. Then later down in our program, we define each function. So the way we define a function that belongs to our class counter is we use counter : that looks awful. Let me try that again. Colon, and then reset. Okay, and now we're going to, all we have to do for reset is set our variable count back to 0. Okay, real easy, short method. Then for the method void counter : count, all we have to do is call count ++. And then, our last one is not a void. I'm making a mistake here. Int counter : get count. We simply return our variable count. Now this is an important concept here. This is a getter or a retriever or an accessor method. Because we have set our data to be private, int count = 0, we can't just call counter.count and get the count. We have to create a public method that gets the count for us. Okay. Now, how do we use our simple class? Well, down in our program, we would create counter, and let's say I was grading tests with this, so I'd create counter points. Okay, then just to make sure our points are set to 0, we can call points.reset. Then we'll write some kind of functionality that waits for input, probably a while loop that reads from the console. And let's say when the user types plus, then we will call points.count. Okay, and when the user types say O for output, we'll call cout points.get count. We'll probably want to make that look pretty by putting an end line after it. Okay. And so this way the user can add to the count by, in this case, typing plus. They can see what the current count is by typing O for output. Okay. And we could even have a function where the user types R to reset, and we call points.reset. Okay, so sometimes we don't want to construct all of our, we don't want to auto-initialize our variables to 0 every time. Sometimes we want to construct our object in a particular way. So taking my rocket example from a few minutes ago, our class rocket doesn't want to initialize all of its variables to 0 every time. It might want to have its mass and its drag and its thrust set specially each time, differently for each rocket. So in our public section, the first method we're going to create is one that has exactly the same name as the class rocket, and that does not have any return type. There's no void here to tell us that we're not returning something. It doesn't have a return type. Now we'll pass into this constructor, say, double mass, double drag, and double thrust. And I should change these in some way from the variables that I'm using inside my rocket, because we're going to have to set them later. So what I'm going to do is I'm going to capitalize each of these variables, since C++ is case sensitive. You could also make it mass 1, drag 1, thrust 1, or drag in, thrust in. There are various ways you can do this. Okay, now we continue on creating the rest of our class here. And then later in our program, we're going to define the method rocket, : rocket with all of these double mass, double drag, double thrust that we put in there before. And then we're going to simply set, we'll set mass equals mass, drag equals drag, thrust equals thrust, and then we can initialize some variables that we do want to always set to 0. For example, velocity in the x direction starts off at 0.0, and velocity in the y direction starts off at 0.0. Okay, this special function with no return type and the same name as the class is called a constructor. Okay, you can have a constructor with no parameters that does the same thing every time, it just sets everything to 0, for example. You can have a constructor with these number of parameters. You can, in other words, overload the constructor, just like we overloaded functions earlier in our programming experience. Okay. So now let's see how we would use that whole thing. So our class rocket, when it's complete, will look like this. We'll have public rocket, we'll have public rocket of double mass, double drag, double thrust. Okay, so we can initialize all of those variables. We'll have void launch, void fly, and we'll have point get position. Okay. Notice that I'm putting a semicolon at the end of all of these function definitions or method definitions. That tells C++ that I'm going to define them later elsewhere in the program like I've been doing. Then private will have a point struct called location, and we'll have double mass drag thrust double Vx Vy to keep track of our velocity. Okay, so that's our complete class, and later on in the program we would define the rocket constructor like we did on the previous page. We'd define our launch and our fly methods to start the rocket going and to continue its flying through the air. And we define get position to retrieve the point location, just like the getter that we had in a previous example. Now here's how we would do then a two-rocket comparison. Later in our program, in our main section, for example, we'd create rocket 1, and we'd have to pass it M1, D1, T1 for mass 1, drag 1, and thrust 1 to construct it properly. And we'd have rocket 2, M2, D2, T2, okay? And then we don't have to keep track of those properties throughout the rest of our program at all. We can call rocket 1 dot launch, rocket 2 dot launch, and then we can create a while loop. Say we create a Boolean called in the air that keeps track of whether these two rockets are still flying. And during that, we're going to call rocket 1 dot fly, rocket 2 dot fly, and then we'll update in the air by checking the position. We'd call rocket 1 dot get position and rocket 2 dot get position to find out if they're still in the air. Okay. So I like to sum these presentations up with a set of best practices and or common pitfalls. The first and perhaps the most obvious is mind your semicolons. Okay. When you've got your class definition, class car perhaps, don't forget that when you define a method, drive, say, okay, we should make it void drive. But you put a semicolon at the end of it to indicate to C++ that you're not defining the function right now. You're going to somewhere later come in and car : drive and define your function there. Okay. Second place where it's common to avoid to forget a semicolon is right here at the end of the class definition itself. In fact, I've probably forgotten that almost every time that I've written out an example in this presentation, because it's not normal in C++ to put a semicolon at the end of a curly bracket. But in this particular case, classes have to end with a semicolon after the curly bracket. So don't forget curlies there or there. Semicolons, sorry. Don't forget semicolons in those two places. Okay. A second common pitfall is don't try to call a constructor directly. Okay, let's say our car object takes a cruising speed as a constructor parameter, so I can say car Porsche speed 95 miles per hour. Okay, but I can't later call Porsche.car, call my constructor, and try to set that to 99 instead. Okay, this is a no-no. If you want to be able to set the cruising speed of the car later, you have to build in a method, Porsche.setSpeed 99. Okay. Remember to make your data private and your methods public. The reasoning for that may seem a little bit odd at first as you start working with objects, because they look a lot like structs, and for a struct you can just call myPoint.x and assign that a value equals 10. Okay, but if point is a class, you want x to be private and you want it to be myPoint.setX 10. Okay. Like I said, the reason for this has to do with when you start writing more complicated programs, maybe myPoint needs to be able to process that new point value beyond just having it set. And myPoint doesn't want any old other part of the program just setting its x value for it. It may be that every time x is set, it needs to redraw its coordinates on the graph or something, in which case if somebody just sets x and it doesn't go through the setter method, it won't know that it's time to redraw the point on the graph. A style point. It is very common to have setter methods. MyObject.set whatever value, set color, and getter methods as myObject.getColor. Okay, other people who use your classes, if you happen to be part of a big programming team, are going to expect to see set and get methods. Another style point is end methods that do not modify your object with the constant keyword. So if I had a getter method, and I'm defining class car, and I've got method get speed. Okay, I would add the constant keyword to let C++ know that this method doesn't affect, this method treats my car class as a constant. It doesn't change the value of my car to get the speed. Unlike quantum mechanics, getting the value doesn't change the value. Okay. Some tips. I forgot to write down my style point. Use get and set. Okay. You can overload methods just like we learned to overload functions. So I can have car.drive with no parameters and car.drive with a speed of 55 miles per hour because I'm trying to obey the speed limit. Okay, car.drive without any parameters might follow that default cruising speed that I had programmed in earlier. Drive 55 would tell it to only drive at 55 miles per hour. These would be overloaded functions because they're getting different parameters. No parameter here, one parameter here, and the compiler will know which method to call based on what you call it with. Okay, and finally, anywhere where you might be tempted to use what are called parallel arrays or vectors, replace those with an array or a vector of objects. Though you could use structs just as easily, but since C++ is an object language, that's our preference. So if I had an array of customers, string 10 customers that held their names, and int 10 phone numbers, customer names and phone numbers, I could combine those into a class customer, which contained, had all my normal stuff, but would contain fields, string name, int phone number, and then I can have customer 10 of customers. Okay. All right. And the last thing that is an interesting little best practice here, because it's a very new practice in C++, is what's called uniform initialization. And with C++ 11, which, believe it or not, even though it's been out for almost 10 years now, is still considered new in C++ world, they introduced a uniform initialization syntax where you could initialize any variable, doesn't have to be an object, using curly braces and the initial value. So I forgot to name the value. So if I set double price $8.95, okay, that creates a double called price and sets its initial value. I could do int squares make it an array, int squares, and I can set the initial values to 1, 4, 9, 16, 25, and I've got the first 5 squares in an array. And then my rocket from earlier, I could set rocket R1 mass 1 drag 1 thrust 1 and initialize it like that. So this makes your code all look about the same, even though you're creating 3 completely different kinds of variables in 3 completely different ways. It's a uniform way to make the initialization setup. Okay, thank you for watching. If you think you learned something, leave me a like, and feel free to suggest any more topics on C++ that you need to know in the comments. Thank you. Bye-bye.